సార్ గుడ్ ఆఫ్టర్నూన్ సార్. ఇప్పుడే స్టార్ట్ చేస్తున్నా క్లాస్ 1:30కి అలా. అవునా, యాక్చువల్లీ నాకు ఇక్కడ క్యాబిన్ ఉంటుంది కదా, అందుకని ముందే పెట్టినా. ఇప్పుడు స్టార్ట్ చేసిన లాగిన్ అయ్యారు పిల్లలు.
చచ్చిపోవాలనిపిస్తుంది తండ్రి అయితే. నిజంగా ఎంత కోపం వస్తుందో నాకు. Yes. Yeah, good afternoon. Okay. So today's class will be entirely based upon the completion of the first unit. So we take all the theoretical part definitions, what we are supposed to do in the unit 1. So you are having how many units? Anybody is having idea in our subject? Units or chapters?
6 units, sir.
Very good, very good.
6 units.
Have you seen the syllabus?
No, sir.
No, okay, I will share the syllabus also, no need to worry. So as per the Polytechnic rule, they will provide us 6 units and certain topics in that 6 units. We are supposed to study all those topics, okay? So now today I'm providing the material also, complete material of the unit 1. You can study this one entirely, and from tomorrow onwards we are going to start the unit 2, okay? The first. So what is the new topic we are going to take here today is efficiency. Okay, I hope the letters are visible, right? Anyone confirm? On the screen, all of you are able to see the letters, right?
Yes, sir.
Yes, sir.
Okay, right, good. So directly we take the definitions, what are the leftover topics. I will show the syllabus also, right? So efficiency is the definition we are supposed to take right now. So what is this efficiency? If you are buying one smartphone, let us say, what is the behavior of the smartphone and what is the lifetime? That means after charging, how effectively you are using without any losses about the signal communication, dialing the number, whether it is okay or not. So efficiency explains the performance of the object. Even if you are buying the washing machine or mixie also, how well they are performing is explained by the efficiency. So mathematically, in terms of the formula, efficiency say is nothing but output power by input power. So any object we are buying, for that object we must have the efficiency. So what is the formula for the efficiency? Output power by input power, or power output by input power. Okay. So if you are taking the let us say fan we are having. Fan input power is what? Electrical. We turn on the switch. What is the output power of the fan? Anyone tell me? It is mechanical energy or electric energy? Output power of the fan. Fan is rotating, right? Whenever any object is rotating, it generates dash energy. Which energy? Any guesses? Let us say you are running. When you are running from one place to another place, you are generating which energy? Mechanical energy. You are moving mechanically. Your body is moving. Therefore, if you want to know the efficiency of the fan, for fan, what is the input energy we are giving? Input power, electrical, chemical or mechanical for the fan in your house? How you are turning on the fan? With the help of switchboard. Switchboard means which energy? Electric energy. So for the fan, what is the efficiency? Output power, mechanical power by input power is what? Electrical power or electrical energy. So in general, we have to remember the definition of the efficiency. So what is the definition of efficiency? All the students, the ratio between the power output by power input or energy output by energy input. So what is the difference between energy and power? All of you? Difference between energy and power. Energy is equal to power into time. We have taken the definition. Energy is equal to power into time. Okay. Now, so let us move to the next one. So in order to study the next topic, which is electrical characteristics of a battery, after efficiency, we are supposed to take the battery characteristics. So characteristics explains the behavior of that particular battery. Okay. So first we have to study the definition of specific gravity. So for your understanding, no need to draw in the examination. I brought this particular image. So everybody must be knowing this image. Vegetables, everywhere we use this particular weighing machine. So what is specific gravity? Everybody know the gravitational force. So specific gravity is the ratio of density of the object divided by density of the water. So if I want to find out the specific gravity of one particular gold, so we take the gold in one particular column and water in another column, and then we calculate the specific gravity of the gold with respect to the water. So battery is specific gravity of battery. How to calculate? You compare with the specific gravity of the water. So what is the specific gravity? We have to write the definition. It is the density of the object by density of the water. It's a small 2 marks, 1 mark question here. Density of the object by density of the water. Okay. So every object specific gravity must be compared with the specific gravity of the water. So now we take the today's most important question here, essay question. What are the characteristics of a battery or electrical characteristics of one of the battery? Example is lead acid battery. Lead acid battery. So in the cars we use, you must have seen huge size batteries in the car, in the buses also. So lead acid battery. So what are the characteristics? So characteristics means what, anyone? Just now I mentioned. Characteristics explains the behavior of the battery. What is that behavior? Okay, we'll see. So first, under characteristics, what we have to write? First heading, side heading is battery capacity. Battery capacity means what? How long it will give the energy. The first meaning is nothing but what is battery capacity? That is how much time the battery gives the energy, how much time the battery can turn on one particular bulb in general terms. But in our subject, as I mentioned, battery capacity means we have to remember the formulas, not the theory definition. So what is a formula? Whenever battery is releasing the energy, whenever battery is turning on one bulb or one fan, we say battery is releasing the energy, or we say battery is discharging. So we use the word discharging current. Whenever battery releases the energy, So discharging current flows from the battery. Okay, so we say ID, battery capacity is nothing but the product of ID. What is ID? Discharge current, units are amperes. So whenever battery is giving energy to the bulb, we cannot write direct that simple word. We must write technically. Battery is discharging the current. So what is a discharge current? Symbol ID. Into how much time it is taking to give electricity to the bulb. So time of the discharge in hours, okay, till the voltage fall to a specified value. So you can write TD is the time of the discharge or time taken to discharge completely. So what is the battery capacity? Battery capacity is a product of discharge current and time taken to discharge. Units are ampere hour, AH, because battery will not discharge in seconds. Battery discharges in hours. So units are current units. So which is discharging current? So ampere hour. I hope this definition is clear. New definition. Battery capacity is the product of discharge current into time taken to discharge. So battery capacity equal to ID into TD. Okay. Now, so what are the next factors you are supposed to write? Okay. So now you can write battery capacity depends on discharge rate. All of you remember, discharge increases, battery capacity increases. So which battery we are supposed to buy which is having high discharge rate? That means if you are buying, if I am telling you, I am giving you two batteries. One is releasing the energy within half an hour and one is working and releasing the energy within 3 hours. Which one you are interested to buy? 3 hours discharge or half an hour discharge? Anyone tell me?
3 hours.
3 hours. Very good. So for every battery, discharge rate should be high. So as the rate of discharge increases, battery capacity also increases. Next, just now I mentioned, every object should have the specific gravity. That's why we have taken the definition. Specific gravity, the density. Okay, what is density of the object with respect to the density of the water? So more the specific gravity of liquid solution, electrolyte. Yesterday we have seen. Okay, more the battery capacity. So battery capacity should be high. So what is a major factor? Specific gravity of that liquid also, which is used inside the battery, should be very much high. Next, these are all theory here you are supposed to take. Now, size of the plates. So as I mentioned, battery contains two electrodes, anode and cathode, which are dipped or placed inside the electrolyte solution. So size of the plates should be high. This is related to amount of active matter present in the battery. So every battery capacity depends on specific gravity, size of the plate and discharge time. Okay. So now we take this is very important definition. Battery efficiency. We have taken general definition of efficiency. What is efficiency definition? All of you? Output power by input power. Okay. The ratio of output power by input power is called the efficiency. Okay. Now, so in general word, I can tell you, you are using the electricity in your house, you are getting the electricity bill also. So if you are getting maximum bill, we say you are using maximum power and you are getting the maximum electricity bill. The efficiency is high there. Output power by input power. Okay. Now for battery, we are having different names because battery takes hours to discharge. What it is discharging current. Therefore, what is the first definition? Ampere hour efficiency. So what is the first hour? Ampere hour efficiency. Okay. So how much current is released during the hour and what is efficiency we are supposed to take. So what is ampere hour efficiency? Very important definition, this one. Ampere hour efficiency symbol is this one, we call it as neta, N-E-T-A, this symbol, it is not N, it is N with certain curve, you can see here. N is equal to ampere hour on discharge by ampere hours on charge. I will tell you the example where we study this ampere hour efficiency means you open your cell phone charger circuit, cell phone charging, whatever the adapter charger you are using, and in the smartphone also they will mention ampere hour efficiency because our cell phone, how much time it is taken to charge and how much time it is taken to discharge. Few people say our cell phone is discharging very fast. So efficiency explains what is the ratio between ampere hours, the current releasing certain during certain hours, ampere hours on discharge when the phone is discharging and ampere hours on charge. As I mentioned, what is the basic formula of efficiency? Output power by input power. For the cell phone, what it will happen? We are going to input is charging, output is discharging. Therefore, what is the ampere hour efficiency? Ampere hour efficiency is equal to ampere hours on discharge by ampere hours on charge. Okay, or you can use one more formula. Ampere means current, hours means time, units. Current into discharge, current into time on discharge by current into time on charge. Efficiency means every time we multiply by percentage means into 100. Okay, remember for lead acid battery 80 to 90% efficiency. That means ampere hour efficiency says that for an object, what is the time taken to discharge and what is the time taken to charge. So if charging time is approximately equal to discharge time, then it is a good smartphone or good cell phone charger circuit. Okay, so ampere hour. So what is the definition? Remember the definitions here. We'll take the problems slowly from second unit. Now, ampere hour on discharge by ampere hour on charge. Now, ampere hour, we can also use one more word for the battery efficiency. Efficiency explains the behavior of the battery. Watt hour, how much power the cell phone is taking for charging and how much power cell phone is releasing. That means if I'm having by battery, how much energy, how much chemical energy the battery is taking to charge and how much electrical energy it is producing, as battery converts chemical energy to electrical energy. So we must know efficiency. So for a battery, what is the efficiency in general? Output energy is chemical, input energy is, sorry, output energy is electrical, input is chemical. So we say efficiency in terms of watt hour, how much power the battery is generating, how much chemical energy the battery is consuming. Okay, in general we say watt hours, that is a power. Watt hour means, watt means power, hours means it is a time. So power into time is the energy. So efficiency, watt hour efficiency equal to watt hours on discharge by watt hours on charge. You can ask one question, sir, why everywhere we are writing discharge and charge? Because battery always charges and after certain period of time battery releases the energy. Releasing the energy is called the discharge. So this definition you are supposed to study. What is watt hour efficiency and ampere hour efficiency? Watt hour on discharge by watt hour on charge. Why we are writing discharge on the above the in the numerator? Because when discharge is the output and charging is the input. Efficiency is output by input. If anywhere any problem is there, not understanding, you can mute and you can ask. Okay, no problem. Now this graph, all of you, this graph you have to write. Okay, draw this one in the examination. Whenever you write the explanation, remember charging or discharging. Yes, any question is there, you can ask directly. So what is this graph? All of you see, y-axis is only voltage and x-axis is time. Only you no need to write these numbers. Okay, only V versus T. Okay, V versus T. So what is this graph here? We say that first charging curve. Let us imagine you are connecting your smartphone to the plugs. Immediately the smartphone will charge? No, it takes certain time. So this graph is called exponential. Okay, in 9th class also you have studied logarithm to the base e, logarithm to the base 10. Okay, exponential formulas. So e power x. So why e power x formula is created means the battery immediately it will not charge, it takes certain time. So this graph you have to draw. After certain period of time, the battery value remains constant and battery will never start to discharge immediately. It discharges slowly, exponentially, and after certain period of time, that value remains constant. So no need to draw this one. This is another any short circuit condition. So how the battery charges and discharges, you must draw the diagram, this graph, the voltage with respect to time. So charging exponential, discharging also exponential and remains constant. Okay, right. So they will ask you explain the characteristics of battery, means up to this point you have tried. So what are the characteristics? I will replay this one once again. So what are the characteristics of the battery? First, battery capacity. Next, ampere hour efficiency, watt hour efficiency. Next, what we are having? this graph, charging and discharging. Okay, right. Now we move to the last class what we have studied. Anyone tell me what is the difference between primary cells and secondary cells? Anyone, student? Or first I am asking, what is the difference between cell and the battery? What is the main difference between cell and battery? Anyone, student? Yesterday's class we have taken. A cell is the basic unit of battery. A cell contains electrode, single electrode, positive electrode and negative electrode and electrolyte solution. Yes or no, all of you? A cell contains positive electrode, negative electrode and electrolyte solution. A battery contains group of cells or number of cells. Yes or no, all of you? Don't forget this one. Now anyone tell me what is the difference between cell and battery? Anyone, student? A cell contains positive electrode, negative electrode and the electrolyte solution. But the battery contains number of cells. If somebody asking you to, you create 10 volts battery. Tell me anyone how many cells I have to place in the 10 volts battery?
10.
10 cells you have to place. Okay. So we have cells. So what is the difference between primary cells and secondary cells? Yesterday I have shared the difference. So primary cells cannot be used once again. They are not rechargeable. They are not reversible. Okay. Yesterday I have taken the cells which cannot be used once again, which can be used only for once. Those cells are called the primary cells. Example, dry cell. You can see the names here today. Okay. Dry cell. So whatever the batteries you are purchasing for 10 rupees outside, those are dry cells. So which cannot be used once again. What are secondary cells? Anyone tell me? The cells which can be recharged once again, which can be reused once again.
Cell.
Rechargeable cells are secondary cells. Where we use the rechargeable cells in all the smartphones, laptops we are using. Yesterday I have given the difference. In this material also it is there. Now, so what are the names of primary cells is mentioned here? Mercury cell, lithium cells. Okay. Now nowadays we are going for the secondary cells only. So what are the applications of the primary cells? Yes, they are used in torch lights, wall clocks, in telephone systems, electronic system, toys, small
Electronic
toys.
Ampere.
Yes, yes, small toys also we have small, basically electric car, small electric car or small toy we can use the battery, which are primary cells. Secondary cells. What is the name of the primary cells? Remember, dry cell. Okay, mercury cell. What is the name of the secondary cell? Read out the first cell. What is the first cell you are able to see on the screen?
Lead acid cell.
Yes, lead acid cell. Okay.
Lead cell.
Yes. So now this is important. We use everywhere the lead acid cell. Nowadays we are using the lithium ion also. Remember, battery means remember two names: lead acid cell, lithium ion. Okay, lithium ion. So we'll see lithium ion is not mentioned in the syllabus. So what are secondary cells? Names we have taken. Yesterday we have seen the differences also. So first, let us see the lead acid battery. All of you remember, explain battery or explain lead acid battery. Both are same answers only. Okay. So yesterday we have taken the definition of battery. Anyone tell me what is the definition?
A battery is a combination of number of cells and it is a electrochemical device.
Very good, very good. What is your name?
Aishwarya.
Okay, okay, right, right. Very good, very good. Right. So whatever the answers people are trying to give, okay, but they everything is counted. We are going to make a note of that one. Okay, listen carefully. That's good. Okay. Now, battery is a yes, electrostatic, electrochemical device, and it is a combination of number of cells, and each cell contains electrode, positive electrode, negative electrode. Negative electrode is called anode, positive electrode is
Anode
called
and
cathode,
cathode.
and one electrolyte solution. These two electrodes are placed inside the electrolyte solution. That same answer we are giving here. So for lead acid battery, what is a new thing we are going to write? You see all of you, the diagram here I am showing you. Okay. So first I will show you the diagram. This diagram you have to draw. Yesterday I have shown you a defined battery or defined lead acid battery or lithium ion battery, lead acid battery. So here the load means bulb. Okay. So examination, this is the diagram given in your textbook. All the textbooks are very old. So we have modified the diagram. We can draw anything in the examination. Okay. So what a lead acid battery contains? Lead acid battery contains two electrodes, positive electrode and negative electrode. Negative electrode is anode, positive electrode is cathode.
Cathode.
Always electrons flow from which terminal to which terminal? Negative terminal to positive terminal, anode to cathode. Anode to cathode. Okay. So explain battery or lead acid battery means a battery is a combination of number of cells. A battery is an electrostatic device. A cell converts chemical energy into electrical energy. A cell contains positive electrode, negative electrode and electrolyte solution. When these two electrodes are placed inside the electrolyte solution, there will be an interaction between electrolyte solution or liquid solution between electrolyte solution or liquid solution and electrodes. Due to that interaction, electricity is generated and that electricity is to turn on the bulb. What is that interaction? Electrons always move from negative terminal to positive terminal. Okay. Now for lead acid battery, the positive terminal cathode is nothing but lead peroxide, PbSO2, lead peroxide, and for anode it is just lead, which is gray in color. Okay, lead. Now what is this liquid solution? H2SO4. Anyone tell me what is the name? Sulfuric acid. Okay, plus water. So electrolyte means one liquid solution. What is the liquid solution used in lead acid cells? Sulfuric acid plus diluted water. Yes, and this is the separator. Separator is just one particular rod which separates both the electrodes. Okay, positive and negative electrodes. Load means the bulb. So here also the same diagram. Lead acid battery contains two electrodes, but the positive electrode is nothing but the lead peroxide. Negative electrode is nothing but the lead. Right. So if any disturbance is there outside, again, please mute yourself now. So entire material is given. So I hope 2 lines you can write off your own. Battery, what is the battery? Then you have to write this one. What is the positive plate here? It is lead peroxide here. Okay, negative plate. Electrolyte is sulfuric acid here. Separators, container we have written. Okay. Now, so as it is, you can remember. Okay, this battery is done. All of you, is it okay? The battery one, okay?
Sir.
Okay, battery container. So few textbooks here, this anode and cathode. Okay, you can follow, you can read this one. Now, this is one of the most important question here. So first, indication of fully charged battery. After lead acid battery, the same thing you can write. The battery definition followed by what we are using inside the lead. The 3 names are sufficient with the diagram. So I hope first we'll see indication of fully charged. So how, see in our smartphone we cannot see our battery. Okay, but if any battery is given to you, how we are going to confirm that it is charged or not? Okay, so as an polytechnic engineer. So first, what are the various indications? Roll number 015, EC015, please mute yourself. Okay, right. Now, indications of fully charged battery. So first indication, specific gravity increases to 1.28. All of you remember this value. Any battery, if the specific gravity just not, we have taken specific gravity will be mentioned for every battery. If the value is 1.28, then we must assume that the battery is completely charged. Gassing. When the cell is fully, it starts liberating certain gases. Gases will be evolved from that particular battery. You can write this line. Voltage. If I'm using the battery of 2.7 volts, the voltage of fully charged battery is how much? 2.7. If you are using 5 volts, it will be indicating the 5 volts. So color. The color of the battery also starts to change. Positive plate between the dark chocolate. This color will be present. Okay, dark chocolate color. So we must remember. So what are the indications of battery fully charged? One is color, voltage value, gassing, as well as the specific gravity. So conditions of fully charged. When a battery is fully charged, how it will be there? So same answer in simple terms. Specific gravity of the liquid. Specific gravity of the liquid increases. Yeah, 1 second. Specific gravity of the liquid increases and it will be from 1.25 to 1.28. Voltage rises. Okay. So the same lines in different explanation, you can write this one. This is a simple theory. What are the conditions? Now we will see the applications. These lead acid batteries are rechargeable. They are used for a large heavy loads, heavy requirements. So emergency lighting conditions. Primary cells are used in torch lights, in small toys. Lead acid batteries are used in UPS, uninterrupted power supply. Means in your house also, if you are having computer, you must have the UPS. Okay. Inside that UPS, we are using the lead acid battery. In the railway applications, okay, substation near your house, you will find the substation where we are going to get the power from that substation. So there we use the batteries. In hospitals also we use the lead acid batteries. So whenever power supply is off in our house, if you are having the lead acid battery, you can use that, you can gain the power from that lead acid battery. Okay. Emergency lighting system. Automobiles for starting. Automobiles means electric vehicles, electric bike, electric cars, we use the lead acid battery. So applications we have taken. Now, so yesterday we have taken series connection of batteries and parallel connection. Anyone tell me, in series connection, dash will increase. In series connection, dash value will increase. Current, voltage or power? Yes, in series connection. In series connection of batteries, voltage value increases. Yes or no, all of you? Okay. Now in parallel connection, voltage value remains same. In parallel connection, current increases and voltage value remains same. The same explanation yesterday. We write here series grouping means series connection of battery. You can see certain batteries are connected in series. The same diagram you have to draw. Load means bulb. We write by resistance. So E is the EMF of each cell. As I mentioned, battery is a combination of number of cells. If I want high voltage, I connect the batteries in series. If I want high current, we should connect the batteries in parallel. Okay. Now, so resistance of the each cell, internal resistance. So only available voltage. So as we are using n number of batteries, n number of cells. So total cells are how much? N into E. The voltage of total cells is N into E. So what is the formula for the current? Anyone tell me? Current formula. V is equal to I into R is the voltage. Current is equal to I is equal to V by R. Yes or no? All of you. So total current equal to V by R. Total resistance. So V is only one battery I am using? No. I am using n number of batteries. So every battery has got the voltage. If E is the voltage of each battery, n battery is how much voltage? N into E. I will show you the circuit here. Don't get confused. In the circuit, we are having how many cells? Anyone tell me? In the circuit, we are having 1, 2, so on up to
4 cells.
Actually 4, but you see in between here we are having dots. So n number of cells. Here you can see dots means it is explaining extension 1, 2, 3, 4, so on up to 100. 100 to last one is n. Okay, no need to write the n minus 1. So if you are having n number of batteries connected in series, yesterday we have seen. What is a series connection? Anyone tell me? Positive is connected to positive or positive is connected to negative?
Positive is connected to positive.
Series connection, positive is connected to negative. All of you remember. Here you can see for series connection, always positive is connected to negative or negative is connected to positive. You can see here all of you. Negative terminal of first battery is connected to which terminal? Positive terminal. Here also yes, negative is connected to positive. Okay, series connection, negative is connected to positive. Now we are having n number of batteries. Each battery voltage is how much? Each cell voltage is how much? E. What we have assumed here? Let the EMF is electromotive force or voltage. Let the voltage of each cell is E. And we are having resistances of each cell. Total voltage is how much? Total voltage of the battery? N into E. Understood all of you? If I am using 9 cells, what is the total voltage of that battery? Tell me anyone. If I am using 9 cells, what is the total? 9 volts. Here we have shown, yes, here we have shown n cells. So n into E. E is the voltage of each cell. So n into E. But we require the current. What is the formula for current? Current equal to V by R. Current equal to voltage by resistance.
V by.
Yes.
V by R.
Resistance is RT we have taken. Total resistance is RT because we are having a number of cells. So we are getting this formula. What is smaller we'll see. Internal resistance. Okay. Now similarly, now you see parallel connection. Diagram you have to draw the same. Parallel connection means what? Positive terminal of first battery is connected to the positive terminal of second battery. In parallel connection, what's going to happen? All the voltage value will remain same, but the current starts to differ. Current value increases. So I is equal to I1 plus I2 plus I3. It is a general equation, a parallel connection. Now, so series parallel you are not having in syllabus. Now I will tell you, take you the last definition. What is internal resistance? All of you remember. Even we cannot provide our 100% of energy. Any human being cannot give the 100%. Every human being is having its own opposition or resistance. So battery also has got internal opposition or internal resistance. So what is the real circuit of the battery? Only positive terminal and negative terminal? No. Every battery has got its own resistance. The resistance which belongs to this battery is called internal resistance. The resistance which belongs to the battery is called internal resistance or resistance offered by the battery. So why we have to draw the resistance here? Because the battery, if I am saying the battery is 10 volts, it cannot generate directly 10 volts. It will generate 9 volts and because of 1 ohm opposition. Understood all of you? If a battery is, if somebody is saying battery is 10 volts means it can generate how many volts? 9 volts or 9.5 volts or 9.99 volts because it has got its own opposition. Okay, that is called internal resistance. So this circuit you have to draw in the examination and then no need to draw this symbol. This for your understanding I brought battery internal resistance. So simple line you can write. What is internal resistance? All of you see here, the cell completes the path of the current from its positive terminal to negative terminal, but due to the closed path, current flows from negative terminal to positive terminal of the cell internally, okay, or current flows from positive terminal to negative terminal. You can read the opposition by the battery or cell to the current is called internal resistance. Same definition. Opposition to the current by the cell is called internal resistance. Units are ohms. Now we are taking the definition of the Ohms law here. What is the Ohms law formula, all of you? According to the Ohms law, voltage is directly proportional to the current. V is equal to I into R. Same material I have given here. Now you see all of you, there is one problem. All of you, the battery voltage is 3 volts. Resistance is 6. What is the current? I is equal to V by R. 3 by 6. 3 by 6 means 1 by 2. 0.5 answer. Similarly, you can check. Battery voltage given is 6. You can just practice. You can this one. Okay. I is equal to V by R. That finishes. Next day we are going for the second unit. This problem also you can substitute. You can try. Any not understanding is there. We will see later on. This is the practice. Just formula substitution only. Okay. Any question is there? You can ask any student now. Last 1 minute it is there. This is the complete first unit material. Next class we start the second unit. Inform your friends, only few students are attending. Yes, ask any question is there, anyone? Okay. Electric iron.